So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with sequences with a focus on arithmetic and geometric progressions. Now, as part of the topic of sequences, it is really important to be able to spot arithmetic and geometric progressions, as well as using this knowledge to find terms and other related matters. Now, what makes a sequence arithmetic or geometric is looking closely at the difference between consecutive terms. Now, if the difference between terms is the same, either increasing or decreasing by the same amount, then we can assume that it is arithmetic. So for example, as you can see in this sequence here, that if I look at this first term, which I assume to be the first term, here I'm adding 4, then to get for the next term I'm adding 4, then I'm adding 4, and then I am adding 4. And as you can see that each of these are all the same, so therefore we can class it as being arithmetic. Now, likewise, for the second one here, we're subtracting by 3. So basically, I'm taking away 3. And taking away 3. And as you can see, as all of these numbers are the same, then again, we can class it as being arithmetic. Now, sometimes you could also say that we are adding minus 3, in which then it kind of works out to be the same when we simplify that to become minus 3. Another common arithmetic sequence that a lot of people forget is 1, 2, 3, 4, 5, 6. Now again, and the reason for why this is an arithmetic sequence is because to get from one term, we're just adding 1. So don't think that you just have to add a number that's more than 1 or take away a number that's more than 1. That just a list of natural numbers can be classed as an arithmetic progression. So looking at this example question, it says the following sequence is arithmetic. Find the missing terms. So as you can see, we haven't got any consecutive terms, but this is what we need to work out. So looking at this, if I start with the number 10, now to get from this number to this number, I'm going to be adding a common difference. And the reason why I know I'm adding is simply because I'm going from 10, and the latest term I know is 37. So plus D, and then that there is going to be plus D. Now, to work this out, what I need to do is recognize that I'm starting at 10. Now, to get from 10 to 37, I need to add 3 lots of the difference. So it's going to be plus 3D, and that's going to equal 37. So if I then go on to simplify this, I get 3D equals 27. So D then equals 9. So what I'm now doing is what I've actually worked out is that I'm going to be adding 9 to each of these numbers. So that therefore means that the next number from 10 is going to be 19, add 9 is going to be 28, and the one before that is going to equal 1, and so there I've completed the missing terms. When the difference between each term is different, there may be a common ratio or common multiple. Here, rather than each term increasing or decreasing by the same amount, it's being multiplied or divided by the same number, and this is therefore then known as a geometric progression. So looking at this, one thing you should be able to spot is that each of these numbers, as you go from each term to term, is being multiplied by 3. And if I took any two consecutive terms, so if I did 81 divided by 27, that's going to equal 3. If I did 27 over 9, that's going to equal 3. If I did 9 over 3, then that's going to equal 3. And as you can see, as each of these sort of divisors are all the same, therefore it's classed as a geometric progression. Now, don't always think that you're in a geometric progression the numbers are always going up, because here, as you can see, what we're doing is we are dividing by 2. And again, if I picked any two consecutive terms, so let's go for 5 over 10, well, that's going to equal 0.5. If I did 10 over 20, that's going to be 0.5. And again, each of these common ratios are the same, so therefore it's classed as a geometric progression. Now, if you're wondering about where I'm getting my divided by 2 and 0.5, well, dividing by 2 is the same as multiplying by a half. So it's both the same thing. So here in a geometric progression, we have what we call a common ratio. So here R equals a half, and in this first example, R equaled 3. Now, common things that are asked in questions is the first one is to continue or find the next terms in a sequence when they tell you that it's arithmetic or geometric. It is also a case of stating the common difference in an arithmetic, so what's the relationship from the term to term, or what is the common ratio in terms of what number you're multiplying to get from one term to the next in a geometric progression. Another example I've seen is where you've got to match up arithmetic with geometric sequences and just state which one's which. You can also find missing and previous terms in an arithmetic and geometric progression, or what we call reverse questions. And there's also going to be links to other topics, notably algebra, replacing numbers with letters in the terms. So let's have a look at some exam style questions taken from some AQA past papers. And there we go. So it says question 1 says the first two terms of an arithmetic progression are shown. The sum of the first three terms is 90, and the question is asking us to work out the value of p. So because we know it's an arithmetic sequence, I need to work out what do I need to add to p to get 5p. Well, that's going to be plus 4p. So that therefore means then the next term is going to be 5p plus 4p, which is 9p. Now it then says that the sum of the first three terms is equal to 90. So the first term is p, second term is 5p, next term is 9p, and that all equals 90. So then collecting the like terms, what I've ended up with is 15p equals 90. So p equals 90 divided by 15, which gives me an answer of 6. Then moving on to question 2, it says here are some numbers, and it says 10, 13, 15, 20, 27, 39. It says that 10, 15, 20 is an arithmetic progression, obviously with a difference of 5, and it says use 3 of the numbers to make a different arithmetic progression and then describe the rule. So what I need to do is pick 3 numbers where the difference from one to the next is the same. So looking at these numbers, well, the difference between 10 and 13 is 3. And 13 plus 3 is 16, that's not on there. So 10, 15, that's 5, there's not 25, no. So 13 to 20 and 27, that works. So 13 to 20 to 27. And the rule is then starting with 13, which is a really important statement, add 7. Then moving on to question 3, it says that all of the geometric progressions are positive. The second and the fourth numbers are shown. Work out the first and the third term of this sequence. So if I just call this x, then I'm multiplying x by r to get 4. I'm then multiplying 4 by r to get whatever this blank number is. And then I'm multiplying r again to get 16. So therefore, 16 divided by 4 must equal 2 lots of r, which is r squared. So here I've got 4 equals r squared, so r equals plus or minus 2. Now it does say that the progression is positive, so therefore r must equal 2. So then what I'm doing then is just multiplying by 2. So to get from this number to this number, I need to multiply by 2. Then that's going to be multiplied by 2. So that's going to be 8. And then going in the opposite direction, I'm dividing by 2. So that's therefore going to be 2. So the first term is 2 and the third term is 8. Moving on to question 4, it says that the geometric progression starts at 4, 16. Work out the next term. So to work out what r is, all I need to do is do 16 divided by 4 equals r. So r equals 4. So then I just need to do 16 times 4, which is 64. Then for the Fibonacci type sequence, so this is kind of creeped in with this. So with the Fibonacci sequence, it's just a case of adding the previous 2 terms. So to work out the next term, I need to add these 2 numbers together, which gives me 3 plus minus 8, which is minus 5. So it's going to be 3 minus 8, which is minus 5. And then adding minus 8 plus minus 5, which is minus 8 minus 5, which is minus 13. Then moving on to question 5, it says which of these is a geometric progression. So again, all I've got to do is basically divide 2 consecutive numbers or 2 sets of consecutive numbers to see which one is correct. Now I could say straight away that this one is going to be the correct answer, because if I take any 2 terms, 3 over 1, that equals 3, 9 over 3 equals 3, 27 over 9 equals 3, and 81 over 27 equals 3. And if I did that with any of the other options, I would notice that each of these numbers would be different. For question 6, very, very similar. So again, I'm looking for which ones show a common sort of ratio. Now I can pretty much discount this first one, so I could put a line through it, so it's definitely not going to be that one. In terms of this, the difference is 1, 2, 3 and 4, so that's not going to work. And looking at the third one, or the bottom left one, I've got 6 over 2, which is 3, 18 over 6, which is 3, 54 divided by 18, which is 3, and 162 over 54, which is 3. So this is the correct answer. Now again, if I did it for this one, 6 over 2 is 3, 10 over 6 is going to be 5 over 3, and that's going to be 1.6 recurring, if I'm not mistaken, which again gives me different answers. Then moving on to the next question, question 7, which of the sequence again is geometric progression. So I'm looking for which one has the same fraction, and it's going to be this one here. And again, reason why is 2 over 1 is 2, 4 over 2 is 2, and 8 over 4 is 2, and each of these numbers are the same.